Hello and welcome. I'm Bill Wake. We're here working on a tune similarity project. The idea is to take some tunes written in ABC notation, at least for starters, and compare them and decide how similar they are, and use that as a musical analysis to help understand the evolution of tunes. We've come a fair ways. We've got the notions of notes and, well, let's see our domain. We've got notes, pitches, tunes, parts, and we're working on bringing in so that a tune knows its parts. We've come a fair ways on that. What we don't have yet is we've always had the notion that a tune knows its notes, and the way it knows its notes today. Let's see if we can. Let's go open tune. It has this field notes, and it also has this field parts. Well, the old way was to look at notes and just as we add a note, add it to the notes field. We've modified it so that we add to the current part as well. But when we go to access the notes, we are fetching from the notes themselves, not from the parts. And we would like to get it from the parts because the arrangement of the tune, let's see if I can find an example. This, no, is it this one? This one. Notice this little notation here, AB2, AC2A. What that's telling us is we play the A section, then the B section, then A, then B, then A, then C. Here's PC twice, and then we play the A for our wrap up. Well, that's a much more complicated thing than just reading these notes in this order. The way we do now, we just read the ones for A, then B, then C. We just assume those are the notes and we don't worry about parts. But I would like our notes, if you ask me for the notes, I would like you to spit it out to me in the order specified by this parts notation. Okay. Well, we left off with a failing test. Let's find that. Okay. So the test says we should see, well, we're saying D4, E4, F4, G4, not FG, DE, FG, DE. And I think I can simplify this test a little and make it just as clear. The B part is the F, so it should be F, D, F, D. Okay, this will still fail, but it'll be a little easier to track down. Okay, and because we're looking for BA twice, B is F, then A is D, then F, then D. Okay. All right, and we got DF, not FD, FD. Okay. In the tune, okay, we specified in the header we put BA2, in the body we put the notes. All right, so when you read the notes, well, that's let's see, you're getting this. I'm not quite sure if this is the best way to go about it. So our notes is basically this sequence type of elements. I mean, you can add the pieces. I guess that's what I want to say is going to happen. So let's see, the ABC parser. Let's keep that around momentarily, at least. Okay, the ABC parser. Well, no, I guess it's the tune, right? That knows that. So the tune lets you ask for the notes. I'm saying that should not be a publicly read-write field. Let's just make it let's see, how can I do this safely? I want to do it in steps and not break everything in the world. Okay, let's say there's private var or just var original notes is notes, and this is going to return original notes, and nobody's going to add to notes. Yep. That's original notes. And where do we add? That should be not legal. Huh. Well, oh, I could do this better. Okay, let's do this. Public, I think I say private set var notes. Let's try that. This goes back to notes. Okay. Yeah, I think that's the way you say it. So it's a public field to read, but it's private for the setter. So at least we're making sure nobody can set them other than us. Okay, and the test that's failing is just this one. Okay, that's fine. I don't know. It's a little sloppy in a way, but I'm paying attention, I guess. I'm refactoring. If I refactor and break this test further, that's probably a bad thing, but I just don't think I'm doing anything that's going to break it further. So I don't know. Commenting out the test really wouldn't change that. But I am checking to make sure it's the only test failing at the time. Okay, so now I've proven that nobody else writes to notes except this class. So let's make that modification I was going to do. So private, well, doesn't matter. Var original notes is nodes. Okay, and I want to make sure that thing gets written whenever this does. Okay, self.notes equals notes, self.original notes equals notes. Okay, and original notes dot add more notes. Okay. This should still be okay. Nobody's looking at original notes yet. Well, that's kind of bad. Original notes. Why is that a problem? Can I do this? Let's make sure we're making a copy. Notes. Well, let's do that at least. So I'm really trying to make sure I don't touch the same. Okay. All right. Why is this? Let's see. So I'm building notes from what comes in. What if I don't do this? Okay, well, maybe I should just comment this test out for now. Okay. Now, adding more notes. Excuse me. I'm copying those notes to there. Why would this break that? Let's do it after, just to. I'm gonna have to see why these fail. Let's see if we can find one that's more explicit. Check tune parsing. Let's go look at that. Well, does tune equality depend on... Okay, let's just run one of these. Rests are allowed. I want to find a nice easy one. Well, this one's more explicit. Not really. We got G, F sharp 5. Notes A4, F, A4, F. Wait a minute. Have I got... No, this is more. Equatable has... Well, this name could be better. Let's say notes match. But I don't see why that's doing anything. Okay, what's this one? One simple song. Expected notes are AFFG. AF, AF, FG, FG. Okay, let's go see the printing. AF, FG. AF, AF, FG, FG. So it's adding it twice. Tune. Notes is notes. Okay, let's take this one. Well, okay, yeah, let's run this one by itself. And we'll break here. I still don't get how adding notes to original notes. Okay, let's make sure this passes. Continue. Okay, and this fails. Who looks at original notes, though? That's the part that's puzzling me. We add to them, we set them up, we start with whatever notes we said, and add notes. Okay, now this test, I guess it's adding notes. All right, let's break here. Run that test. Okay, let's see the notes we're coming in with. More notes. Oops. A, F, F, no, A, F, G, G. Is that what we expect from the test? A, F, G, G. Okay. All right. So we step over. Okay, let's look at original notes. Why are you AFGG? Wait a minute. Because we haven't executed this line yet, so it's already there. All right, let's go to the constructor. All right, I'll rerun this test. And let's go look at check tune parsing as well. But all right, let's see the notes. Empty. Okay. Where's check tune parsing? Note lines, empty, expected note names. Oh no, header lines empty. Note lines is the string we've got. Expected note names. Okay, let's break here. Notes is empty. Original notes is empty. Okay, and more notes. You know, I think I would be helped if this were easier to read. A, F, G, G. Okay, so it's, I don't know if we can do this. No. Okay. Let's step over. Now if we print notes, that should have AFGG. And original notes should still be empty. What? What the heck? AFGG. Have I tied these in somehow? Original notes is notes. Okay, I'm going to step over. And now look at original notes. Original notes. Hoons.lastbang. Original notes. What the heck? It's like they're over aliased or something. Original notes. okay, I gotta do this again. Something weird. I'm looking for that. Yeah, this one. Okay. We should break it. Check tune parsing. Okay. Let's make sure these are what we think. Header lines is empty. Note lines is AFGG. What? I don't know. Space between notes. Okay. So we're okay. Let's do this. See, notes is empty. Okay. So print notes, print self.notes, print self.original notes, all empty. Okay, I'm going to continue. Somebody's calling more notes. Add notes. More notes. That's AFGG. Okay, print self-subcurrent part. AFGG. Okay, so the current part started empty, added those notes. This added those notes. Now, original notes dot is empty. Okay. Step over. I've got something. This is. Maybe I really do need to copy that object. Why is it not creating this issue here? I don't know. But it's like we've added them to the this. Let's look at more notes. It was 4 things. Oops. Okay. More notes. Okay. Still 4 things. Print original notes. Has 3. What type is notes? It's a notes. Where's notes.add? Self notes append. Well, I want to. The change I want to make, maybe I should just push that through and see the consequences. I want to make this be public notes of type notes, and the value should be original notes. I think I must be writing them twice or something, but that goes away. And this goes away. Okay, let's see how they deal with that. Build failed. Okay, I think I'm trying to eliminate the thing that caused that original problem, but I feel like something is appending, like two things are pointing to the same object and that object changed rather than having independent objects. So I really only want to have one object. Actually, I don't even want original notes around at all, but let's check this in since it's working. Um, so switch tune to manage original notes and treat notes as a derived value. Okay, that's kind of what we've done so far. Now, I think I'm setting up a change. Yeah, let's set up the change. So find that test that we had before that we ignored. Now this should still be failing. Okay, and its problem should be that it's coming up DF. Okay, so let's focus on, let's make this better. I don't know if I think I want this better. I'd like this to just read DF and FDFD. Maybe spaces between them. I don't know, but where's note? Okay, so we have a custom string differ. Okay, note name. No, wait a minute. Who's putting the word note in there? Accidental octave. That's actually okay. I don't know I don't need the octave for 4, and if I just well, okay. I guess maybe it's notes that's throwing that note stuff in. Yeah, notes map. $0. Well, somebody must be attaching the word notes on there. Hang on. Right? And that's not a reference, it's just text. Nobody claims it. Okay. Notes. To create this, we just join them with separators. Map each one into its own thing. Okay, well, what are we mapping? We're mapping the notes, which are, musical element. Maybe it adds it. Musical element. Does it have a print? Notes. I'm puzzled. Okay, where's note? Oh, maybe that's, no? Okay, what's, what if I make this just custom string convertible and make this description? Who is putting in the word note? Okay, let's find again. Let's just look for this. Nope. Okay, so maybe it's notes. Maybe I could do the same thing here. Let's make this a string convertible. Take out the debug and run that. Now, assert failed. Maybe it's that we got notes.map. Okay, notes is where we have musical element. Maybe it's that musical elements don't have a description. Okay, so if we do this, we kind of have to do this case. Note let value return value.description. Okay, so that gets down to the actual note as opposed to a musical element. Again, we'll run. I'm just trying to get a more readable. That's it. Okay. That is better. All right. So let's ignore this and make sure everybody else is happy. Okay, this should fail again. Good. All right, so we're getting D4, F4 instead of FD, FD. All right, so now I want to make tune. Well, what I want to do, I want to accumulate. I want to make a reduce. Well, what I want to do is go through the parts. Part specification, parts description is actually what we want. Okay, so this is the AABB fully laid out version of things. So if I go through the parts description and I map each one to parts sub $0, okay, that should give me that takes each part, maps it to its notes, and that should give me then an array of notes. And then I want to do a reduce. And I always have to get this thing right. Initial result is notes, and next partial result is a method taking the result and the notes. Result in optional notes. Well, let's get rid of the optional here, because we know our lookup is always returning 1. Do we have, oh, I guess we could just use subscript. Oh, sorry, I'm losing my place here. Let's look up in self. Okay. And now reduce. Partial result is a notes. Okay, so what's this one? No, let's do this one. So initial result is a notes, and then the expansion is notes in. This is going to return a result. Okay, so the result is type notes. So result so far, result dot, come on, result dot, oh, you're supposed to be a notes. Oh, missing a print. Okay, so we start with empty notes. I don't think we even need to say that. I think that's the default. Okay, so result dot add, and then notes type is notes. No. Okay. Result dot add. Well, I want to say notes or notes. Let's see, does notes add notes, or does it add an array of notes? Oh, it add notes. Okay. Result dot add notes. Okay. Can I convert type empty to closure type notes? I guess we got return result. Okay, and then I think this is what's coming back, not original notes. Okay, so when you ask for the notes, we're going to look up, go through the parts description, pull out all the notes for that parts, and then given that array, we're going to reduce it by starting with an empty list and then basically accumulating each one of those into the result. That gives us one large notes object, and that should be it. Okay, so I'm claiming that's going to work. And it works even less than I thought. Okay, so what's going wrong? Let's check this one. Well, where's the test we were running? That's the one we really want to look at. Okay, this one still fails. FDFD is not equal to FDFD. Well, that's... Okay, if that's not true, then that explains something. FD. Okay, so how do we compare tunes for equality? Well, we check that their notes are equal. Well, notes Notes is a complicated object. I think we need to check that. Oh, yeah, we need to make sure notes is equatable. And it is. And then notes, the lowercase, is an array of elements. That seems okay. Let's see one of these other ones. What are they? Do they look the same? A4FFGA is not equal to nothing. Nothing. Now, wait a minute. Ugh. I don't know if I'm on a bad path or not. Let's see. How do musical elements check for equality, right? Let's do note. Okay, our notes are the same if their pitch is the same, the name is the same, the accidental and the octave. Okay. Where's musical element? Is that up here? Okay, that's says they're the same if notes are the same. Oh. Okay, let me go back. A simple song, key of G, A, F, F, G. Okay, so let's see what tune sub 0. Key name G, F sharp, A, F, F, G is not equal to the title. Title key G and empty notes. Oh, now this one's different, right? Because we don't know. Oh, sorry. Let's see. So this one has no parts, so it's implicitly A. I don't know if this. Maybe this is not building right in that case. Okay. I thought our descriptions took that into account. Part specification is part. Okay, it defaults to A. All right. I don't know. Okay, that's errors, so we don't care about that per se. Build a simple song following the file header. Okay. And let's stop at tune equality on this one. Okay, so let's print the two tunes, LHS part spec A. Okay, this is what we got back. It's got original notes, A, F, F, G. The A part has A, We can't quite see them, but there's 4 of them. I'm assuming they're AFFG. Okay. LHS.notes. AFFG. Okay, let's print right hand side. It's got an A part. Nothing in it. Okay, original notes is fine. There's something about how we're constructing these. I think it's the initialization of the expected value here. We're putting these notes in notes, but I don't think we've put them in our A part. So we stored original notes. We really need to put that in the A part as well. Self, part sub. Part specification. Let's just use the letter for now. Part sub A equals notes. And I may be getting that double thing again. But I think notes is more for the test case. Has a key. Okay. LHS sub A has 9 notes in it. That's excessive. I don't even know how it gets. Oh, it has 10 notes in it. A, F, presumably F, G, F, G, A, F, F, G. Okay, these failures are going to be different though. Well, let's get up to this one. G, A, F, A, F, A, F, A, F, F, G, F, G. It's not equal to A, F, F, G. A, F, A, F, F, G, F, G. Why is it adding twice? Okay, but maybe this is where this goes away. Okay, so we're not looking at original notes anymore. So let's not add to it, because I think that's mucking things up. Okay, one failure. That seems more like it. FD, FD is not equal to FD, FD. Okay, that sure sounds equals. All right, now we can go check our equals. Let's do tune equality first. We'll do this. We'll run this test. Okay. Let's break here then. So it's not checking tune equality. It's really just checking the notes that come back. All right. So try again. Okay. So let's see tune.notes. Well, it's got FD. Hopefully this is FD. FD, and then let's print notes, sub expected notes. Description. FD. So notes, let's see, notes is equality. Well, musical elements are equatable. No, that wasn't notes, it's equality. Okay. Notes are equal if the notes equals the notes. And that's lowercase notes, which is the array of musical elements. Okay, musical elements are equal. Basically, this is saying take the default, which should be that they are equal if their contents are equal, assuming these are equatable. Okay. What do we got? Accidental end key. Note name D. Is the key right? F in key octave 4, D in key octave 4. F in key octave 4, pitch 65. Pitch 66. Right, they're in different keys. Let's go back to our test. Have we done this in the key of G? And here we said C. I think our default, where is that thing? Parse tune, yeah. Key of G. Okay. Let's make that work. So I think we need to make this more correct. Oh, excuse me. All right. Anyway, we need to make this the same key as we're looking at. Okay, and accidentals. Well, let's find this. Do we have that up here somewhere? No. Okay, find that. G, accidentals. Let's just take the rest of this. And our failed test is here. Accidentals. Key of. Let's rename this to key of G. All right. Now it should work. Okay, let's run all those clean. All right, so that's actually working once you say, hey, this tune is really in G, and your answer should also be in G. Okay. Good. Let's check this in. Make notes be calculated from the parts description, not just whatever order they came in. Okay. That's a good point. All right. Well, we are due for a break, so let's take that break. I'm not going to try and upgrade this app here. We're due for a break anyway. Let's take the break. We're going to come back. We're going to do some cleanup. We've got this this key of G is, we've created it several times in tests. Let's get it out there and name it. It might even be handy to have it in as a constant on key. I could see that. So we're going to do that. We've also got AbcParser getting large. I think we've grown it again with this parts handling stuff, and I want to pull that out. I think we really need to break this thing up and deal with these the need to parse. How do I say this? The line parsing we're doing. I think we need to kind of move that up a level and break out the pieces that need to be broken out. If we do that, well, recognize P code in the body, pull notes from parts, eliminate notes field. Okay, I think we've mostly done that. Yeah, we got to get rid of original notes and stuff. So we got some cleanup to do, but we'll come back and do that. But for now, take a 3-minute break, and I'll see you when that's over. Thanks. Hi, welcome back. All right, let's clean this to-do up a little bit. Okay, so this is all part of recognize the P code in the body. Pull notes from the parts we've done. And then eliminate the notes field. We have not. All right, so let's do that. Original notes. Nobody should be caring about it anymore. This can go. That can go. Okay, so now we're doing all our tracking of new notes in the current part, which I believe is what we want to do. I still have some doubts. There's two things going on with this. One is it's got this process of accumulating the pieces as things come in, and then using it as a complete object at that point. I don't know if I should be splitting that off. So the current part specification, see, they may change that. I think in some ways this is okay. It's saying we're gonna work by default in the A part. Okay, the current part is A, and we're going to do this. So I think maybe we can we reference that already? We might not be allowed to. It's being part of the constructor. There's little subtleties in initialization between like Java and Kotlin and C# and Swift and every other language, right? But that looked like it built. Okay, so I feel better saying that. So the part.specification, I'm gonna take this too as current part. So I'm saying we're defaulting to just an A part, which is true for most things. If they don't specify it, it should default. Okay, so we eliminate references to original notes, and we made initializer use current part. Okay, but this notion of current part and even like current key, that's kind of a construction time thing. Once you have it, I don't know, maybe you don't care. But parts description is a string. I can't really ask that. Okay. All right. So one thing I mentioned was this Key.ofC. Like maybe, let's see, can we make that static in key? Where is key? Oh, I'm just visually missed it. Okay. I mean, if you had, I don't know that I need everybody. Like it'd be kind of ridiculous to create them all. I think. Key signature to accidentals. Well, that's kind of, that's there statically. Key signature. Let's go see what that is. That is the numbers and the, so like 6 sharps. Oh, function of key signature is already a thing. Well, let's see what key signature is. Blank, yeah. Make key to accidentals map. What does it do? It knows the sharps. Does it add one in for C? Yeah, 0 natural. Where's the name though? I mean, it's like it almost knows it. Of key signature, I'd almost like to ask key names, right? Here's that. Make keys is called where? Find selected symbol. Okay, it's called by make key to accidentals. Okay. Notes by fifth. Okay. So the keys come in the order. Key names. Notes by fifth. I mean, there's definitely something going on here. Key signature accidentals. Key signature. See, array. Oh, so if you ask for any number of flats or zero of anything, you get that. But I don't know if this make keys has the key names, sharps, and the notes by fifths. How is that right? Make key takes the key name as a string. Order of accidentals, notes, 0, 5. Five is the octave. It's so close. I just don't think I quite have it. I don't have a map. Like, let's see what there is. I have a map of key signatures, which is not bad. And then the key has a name. And what does of do? Of returns a set of notes. Given the key signature. I don't know. I think I want to say, let's find. Sorry, one of these tests. We know we have G. We probably have C as well. Key of C. Okay. Let's do this. Key. That's kind of a generic of. I want to make a static func of C. I want to make a static variable. Now, could I do this? It returns. Why is it returning? Who calls this? That's suspicious to me. Key parser. Okay, this is mapping the key signature names to their things. That, again, is sort of like what we want. But the names here, they're defined. They're defined as according to ABC notation. This is a parser, so it's dealing with the input formats. But we're trying to get to the real, just like from the note level. And this accidental, we need an F sharp in it. Accidentals, let's take that. A key. Okay. Now in here, I think key of C. All right, if I take these two out, right, somebody should complain. Right, okay, so key of, key.ofG. Okay. do I like that better? Okay, and then these are Key.ofC. It's a little weird that I don't have them all. Okay, let's make sure this works. Okay, let's do that at least. Key of. Okay, this is Key.ofG. Let's see if anybody else does this. Key of Tune. Well, that definitely can go away. And let's just see who's building these things. Oh, I guess we got to search for a text key. All right. Everything should run. All right. Key. I want to pull these up. And I think I actually want to pull this down. Now, it's kind of a question if this should be its own class. Key is big enough. I don't know. I think we're okay. All right, now I was worried about AbcParser. Let's see what our to-do says. We've done that. Okay, now we're into refactoring. Well, what do? We did that. Okay, now I think this file, there's too much going on and I'm not necessarily happy with how it's doing it. Okay, now these are actually parser functions, and I think maybe we should pull them out. They're more associated with pcombo. Okay. And I'm gonna say we pull them out. Let's make Swift file. I'm gonna say pcombo plus extensions. I don't know. It's kind of a generic name, but I want to pull these methods over there. Well, we'll have to import pcombo for sure. Okay, so let's see. I think what this overall parser, I think it's going to need to know all these parsers, but I don't think they belong in this file. And I also think parse it as a helper, fine tunes. So let's see. Let's get down to that big. Okay, fine tunes is the kind of main parser method. It creates, wait a minute. What are we in? AbcParser. That's the whole body, all right. Okay. Why a method here should create a parser when it's already on the parser? I'm a little skeptical. Who uses that? Everybody. Oh, that's text. No. Well, let's just look for parser in here. Find parser. If I say parser equals self, what happens? Because nobody can call fine tunes unless they are already an AbcParser. Okay. So the thing I think should happen, we have all these tune header lines. The plus we haven't dealt with. I don't know if I want to, but like we've been working on P. All right, there's all these others. Another one we're going to need at some point, L and M. I think M is the meter and L is like 4/4. L tells you which one gets the beat or something like that. There's something going on. R, I think, is just from mark, and that we can mostly ignore. Many of them we can mostly ignore. But what happens is we're in here, and we got line starts with X, do a bunch of stuff, and then line starts with T, do some stuff, and if it starts with K, do some stuff. And if it starts with P, do some stuff. And what about down here? It could start with K or P, and we do the same stuff. And there's something off about all that. What I think I want to do, and that may be more than today's job, but I feel like this one is a P in the header area. Okay, so this is the header part parser, and it does some stuff with the tune, and it does this, and it sets up a new state. And other ones we're just ignoring, but I feel like this tune header starts, that was that list, that's the list of characters that could lead a tune. I feel like if you start with one of those, then you should have that list should be more of a map. It should be a map from the start to a parser or some parser like thing. Now, P-combo doesn't really take in a current state per se, so that it's a little more complicated, but there's, and this is also a little more complicated, that you need to parse it and update tunes. You need to parse it and update tunes, and sometimes you need to update the state, but not always. Down here, there's no update on the state after the parts. Okay. It's a pain. But I do feel like these things that it knows how to do, like that much, should be a little object. Now, title parser, I don't know what's involved. Or I should say, I don't remember what's involved. There is this, like this definitely could be on that little object. Make a title parser. That seems like a fine thing for it to know. Okay. So I want to do that. Okay, so make title parser is one piece of it, and then the other piece is that action we do when we see it. We do a parse it and add title and state gather titles. Can we do that in gather titles, state gather titles? That's fine. I think this entity I'm looking for is we give it the tunes because it's going to change them, and we get back, I think we get back the new state. But that seems really unfortunate. Like, why is current key in the parser? It does it really need to know the key? I don't know. Let's find usages on this. And I don't know, I'm bouncing around a little. Oh, nobody's looking at it. Good. Okay, so theoretically I could take these out. And this. Right. Tune state. Current key. Okay, does anybody reference this? There it is, note parser. Okay. So I can't take that out. Grr. That is unfortunate. I mean, maybe I should be able to. Oh, there it is. Okay. I knew there were two. All right. Those. Why does the parser need that? See, I was trying to get some way to pass the state around to the things. But maybe maybe that's the tune that cares. Like this. I don't know. Okay. Let's start down this path and see. I think there really is something. This is like this title parser is a thing, and we don't make a class out of it yet. So let's do that. Let's make a title parser class, and maybe it's header title parser. Okay, so I'm saying that exists, and the method on it is that title one. So I'm kind of trying to pull out state that corresponds to these match T colon not new lines. Take everything, strip the spaces off. That gives us one valid title parser. Okay, and then title parser in here. I'm saying this is a method that is it takes a line and a list of tunes. Okay, so this method is, well, let's take this stuff, and it's going to return a state. And I'm just kind of trying to get the pieces in, but function do it does something, and it's going to return something, and it's going to look like this. Okay, state is private now. Okay, states, do we have those out yet? No. Okay, this is the parse state. Let's find gather titles. Oh, that's actually helpful. Enum parse state. Okay, let's pull this up so we can reference it up here. And this returns a parse state. Oh, that goes a little further up. Okay. So this thing needs a line of type string, I believe, and a tunes of type tunes, and it returns a parse state. Okay, so let's return this. Okay, parse it. Oh, is a helper method. Okay, I'm going to move this out. Oh, line is a substring. Okay, that's good to know. Okay, gotta make this function be more public. Parse it. Okay. Then down here, this should be a substring. Is that one S capitalized? Yes. Substring. Okay, and then parse it. Now what's its problem? Parse error is not in scope. Parse error. Okay. All right, now I think what I've done is, oh, not quite. All right, let's make it a init. And let's make a title parser. Parser is cbind of string. Okay, so the parser for this thing is make title parser. Okay, and now in here we'll just reference parser. Okay, that's the title parser. Okay, one more error. Errors thrown, and this thing should say throws. Okay. Oh, still one more error. Yeah, I was afraid of that. Okay, make title parser. Match dematch that string returns to parser.parse. Wait a minute, why is that true? Self-Houston method call. Oh, let's do a defer. So we can tell it, I'm just gonna build, I promise I'll build this, and then do it at the end once everything's initialized. So I think we have to put a bang on there, but let's see if it, yeah. Okay, so I'm saying I promise there will be a parser defined before anybody uses it, and in here I'm defining it before the initializer completely finishes. And so normally init runs everything, and then at the very end it will run the deferred part. But the bang says I promise not to use it before it's ready, and we build it in the initializer. What this does is it lets me call a local function even though the full object is not initialized. Okay. So we build t : not new line, return the stuff, and we are binding into this parser. Okay, the parser here. Okay. Do it. I don't have a better name yet. Parse the line, and given the tune state, then we return that. Okay, this should all work because we're not calling anything. We've changed, we've moved stuff around and all that. But pull out a header title parser class. Okay, now can I make this thing use it? That's another question. Okay, I think the right word is probably parse is the verb we want. You say parse a substring with a given state context, and that does the job. Okay, so it calls this parse it method. Okay. And we're not referencing anything that's not passed in, so that should be fine. All right, now let's go find the usage of make title parser. Well, where should the usage be? Down here. Okay, here's fine tunes. Title parser. Okay, we require a T, then it really should be that. Okay, so let's build this thing at the constructor time. Okay, so we've got this. We're going to build it and hold it in here. Okay, so header title parser of type header title parser. Okay, and well, we can do it here. Header title parser equals header title parser with a capital H. Okay, so we've constructed one. There should be no harm in building it. Well, apparently, what do I know? Self is used in method. Oh, with a bang. Okay. We're building it but not referencing it, so there should be no harm in that. Okay. Okay, and then down here, in tune gather titles, required title. Okay. We should be able to say state equals header title parser dot parse line and tunes. And that should be the same. Okay, as our parse method was doing that stuff. Yes, I did mean to use try. Okay. All right, let's make sure this works. Okay, that's a step forward. All right, now we have this one. We are doing the same thing. The state is unchanged, but the state is gather titles, so that should be okay. This is where I'm not sure it's always going to work out, but let's let state equals header title parser dot parse of line and tunes. And that has a try on the front. Okay, so let's take these out. And I don't know if we may need more stuff going in. Where's our other title parser? Gather titles. No, it should be above the require T. Oh, very simple. Okay, yeah, the only thing you can do in requiring titles is match one, and if that fails, then you failed to batch the file properly. Okay, so this works, but now nobody's referencing title parser. Okay, so we make title parser. Now this one should have no references. Okay, we call make on it. Oh, we have a test that uses it. Okay, what can we do? I think we're probably being a little nosy, but let's say let parser equal parser dot title header title parser dot do we have access to that? This is duplicated. Okay, the value of type cbind. Okay, yeah, this cannot take that. We need the parser itself. Okay, let's go to header title parser. And this may be too snoopy. Test may be a little overcoupled. Okay. Right. Okay, I'm going to try and do it. Okay, I think we're saying it must be there just like we said it before. Okay, does everybody buy that? All right, well, let's do this. Okay, now I'm still trying to get rid of title parser. All right, I think I can now. Should be one reference in here. Here it is. Okay, and we're doing a different parser instead, I think we need to keep track of it. Because our overall parse state thing is the thing that knows about the header parser and when to use it. So I think we do need to keep track of the different various parsers, but I think we can simplify it as we get things more similar here. Okay, so now this is more separated. Okay, the only thing we do is create the reference and use the parse method on it. Let's pull this into a class, header title parser. Okay, hopefully that's resolved. Why it says it can't find it when it works. Let's do a clean. Oh, there it went. Okay. That was everything, right? So pull header title parser to its own file. Okay, that's the kind of thing I want to do here. And I'm hoping this works. That's all I can say. So if that was title, we use that twice. All right, so now I want to do the same thing with the key. Oh, this one's going to be uglier. Maybe I want to do it with the P. Okay, because we got two of those too. State equals Intune header. State equals Intune header. They both push into Intune header, so that's a good thing. I think the K is going to be the tricky one. K Intune body. Oh, Intune body. Okay. No, that seems okay too. All right, let's do a header parts parser. The name is kind of taken here, but header title part. Okay. Let's make this old. Well, that name could be better. Just kind of calling attention to it even. All right. We're going to do the same process though. We're going to find the header parts parser. That's in the P sections. Okay, if line starts with P, we want to get this thing. Well, this is our parse method. That much we know. Okay, so let's make a class. And this is the parse function. which takes a line of substring and a tunes of tunes, and it returns a parse state. Okay. And this becomes the return header. Okay. Now we need to build that thing up. Well, let's find this header parts parser. Got to be assigned in here. Okay, make parts parser. Oh yeah, I don't think we need that anymore. Make parts parser. Okay, let's give this an initializer. Well, the parser itself. Parser is a cbind of part. Bang. Init, public init. Okay, we defer, and then we say parser equals make parts parser. Okay. Anything in here that depends on anything else? Oh, here's build repeat, build parts. And that's different. Okay, where's build repeat? Build repeat, build parts. Okay, what else is going wrong? Try parse it. Okay, instead of being on old parts parser, we want this to just be on parser because it's the local one. Parser is returned here and built here. Okay. Errors thrown. Oh yeah, this is a throws. Okay. That should be okay. Nobody's calling it. All right, now I should be able to get rid of some dead code on the title one though. Make notes, make reference, build reference, make title parser. I don't think anybody's referencing this. Good. Okay, now I should be able to use the parts parser. Oh, we need to make one just like we did the other one. Okay, so let's make a header parts parser. Of header parts parser. And then in our defer, we'll do header parts parser equals header parts parser. Okay, we're building it, but not using it. Cannot. Okay, let's try that again. I think it was just I bumped something and it kind of woke it up funny. All right. Well, I could check in, but it's not really doing anything yet. Let's push that. Create but don't use header parts parser. Okay, now let's go look at header parts parser. Header parts parser, and notice its parse method, it returns in-tune header. We got to make sure that's consistent on both branches. Okay, so here's P with the parts parser. All right, so now we want to say state equals try header parts parser dot parse line and tunes. Okay, and it returns in-tune header. So that should be that. And then down here, if line starts with P, oh, that's not the right one. Up here, this is state equals header parts parser dot parse line and tunes, and that should all be in a try. And again, this should go away. In-tune header. So tunes.setSpec. Okay. Okay, so now we're use header parts parser. And let's get rid of the old one now. Up here somewhere. Okay, old header parts parser should go away. Okay, and so let's look for old. And then the helper functions, build repeat, build parts, and make parts parser all go away. That should still work. Whoops. Tests. Okay, kind of similar. We're going to say let parts parser equal parser dot header parts parser dot parser bang. Okay, and take out this one and run. Whoops. Okay, that's all good. Header title parser we don't need. Extensions. Okay, ABC parser. Okay, we got rid of all those references to old. We got rid of these. All right, make sure this is all good. Okay, remove dead references to old header parts parser. Okay, and then let's pull this into a class, into a file. So this to here is header parts parser. So we'll need a new file. Okay. Yeah. All right. Let's see what. Oh yeah, we've cut out. I don't know, 80 lines, 100 lines. Boy, this thing. Oh, okay. Well, maybe we can pull out reference number and notes as well. My notes is the more challenging one because I think that's the one that dealt with that key thing, right? I don't know. Can we get rid of that? Well, maybe we take care of reference number first. Okay. Reference number parser. Let's find the references. Okay, reference number parser. I think we'll do the same kind of thing. Let's rename it first. Old reference number parser. Okay, and then the use of it there. Well, we know it's down here. Now this is not a local variable. Oh boy. Containing, let's match word. Okay. Init. Tune.reference. Where's this? The report. Okay, tune reference number, that's fine. Why doesn't the parser have that? Let's try and make this local, more local. right, so we make variable reference number be more local so we can extract parser. Okay, now line starts with X, reference number parser. Okay, so I think like before, we're going to make a new class. Am I better off down here? I don't know. And this is another header reference number parser. And this is function parse. It takes a line. It takes a tunes. It could throw, and it returns a parse state. Nice. Okay. That's gonna go away. And this is a return. Okay, so we need to find old reference number parser. Well, no, we need to make a parser. Oh, I guess we don't know what it does. I think it's returning int. Var parser is cbind of int. We need an initializer. And then defer. This gets a bang. Okay, here's make reference number parser. And it references this. Oh, it's returning into question mark. I'm going to copy it out for now. Spaces and digit. Okay. I think those can be yeah, let's move this up. Okay. That should make that build. Ugh. Okay. Oh, we need just parser. Okay, parse it line, append. Okay. And this should build. No one's referencing it, so it's no harm. Oh. Okay. Make reference number parser. Maybe these need to be static. let's pull them back in. Oh, I've got them here. I'm going to make them my own local copy. I think that's actually okay. I guess I could have a place. Well, wait, who's calling this? I deleted them, didn't I? Why I defined the one and not the other? I don't know. Okay. We're using the old one. We don't have a new one yet. So we need a field. This comes before it. Header reference number parser is a header reference number parser. Bang. Okay. And then down here, okay, so I'm creating it but not calling it. All right, now let's go down here and call it. Starts with X colon. Okay, so this should be the place we call it. State equals try header reference number parser dot parse line and tunes. This stuff goes away. Nobody else is looking for X's because it's only the first line of a thing. It's not allowed again. Let's see how that goes. Okay. Delete that. Okay, now nobody's referencing the old one. No, except a test. Okay, let's switch the test over. Parser dot header reference number parser dot parser. Bang. Okay, that should be good. Oops. Okay, and AbcParser. Old reference number parser should go away. The reference to it should go away. Reference number parser should go away. Build reference should go away. Okay. And finally, let's pull the file out. All right. So we've done that. This refactor pull out separate parsers. Pull out parsers to separate classes and files. That's what we're doing. Okay. I probably want to refactor pull out corresponding tests to new test classes. But we're still embedded in this. All right. Now this is getting smaller. I mean, a little bit at a time. Let's see. Did we delete everything yet? I think we maybe still have some reference number parser functions in here. I don't know. HTML. I would like to get rid of that. No, I guess we got rid of those. I thought that would take a few more lines out. All right, now this. Well, I feel like this put split where separators new line. Where is this used? All right, who's calling this? That's in fine tunes. Okay. I don't know if this is a 5-minute job, but what it's doing is I guess you give us a substring and we want to normalize the line. Let me pull that out as a function first then. Public func normalize line yields back a substring. Raw type I'm not so keen on, but it's going to return this. Line. Okay. And then this becomes normalize. Now this well, I don't know if it's a 5-minute job or not, but let's start it. Let's pull these out. Let's make an extension class. I think extension substring. Let's pull these two things in. Okay. So entity to string. Where does that guy live? Entity to string. Oh, that's this thing. I definitely like getting that out of here. Of course, I can't put it in there because extensions can't have data. Let's pull it up a level and deal with it that way. I don't know. I'm leaving some global structures. Okay. But that lets me make an extension. Okay. And then I got to get the input off there. This is input. Can do that. Okay. Now my normalize, where'd that get off to? I should be able to say line dot eliminate dot replace. Okay. And these go away. Oh. Okay. We'll have to deal with those tests. Okay. Okay, just a minute. Maybe a 5-minute extra today. Let's pull this into a file. Okay. And this is, it's an extension, so it's stub string plus normalize, let's say. And I don't think we need any helpers. Okay, that's all that stuff. The test should still not build. Substring has no member. Oh, that went away. Okay, good. Let's take these. Parser dot. Well, now it's really this. And same thing here. Let's see if I did this right. Substring. Okay. So the dot 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 thing converts a string to a substring. Notice we're already using it on the right hand side. Okay. So we extract normalizing functions to substring plus normalize dot swift and modify tests. And this is another example of tests that probably should be on a separate thing now. Maybe more than probably. Okay. All right. So pull out parsers. We haven't finished. We've got all but one so far. Pull out tests. We haven't done that. So I think we've got more refactoring to do. I do think this is, it's improving. Okay. We've cut about half the lines, or, well, we've cut half the lines out of this file. We've moved them to other files, but I think we are improving it along the way. So next time we'll finish this notes one, and we'll fix those tests to refer, more specifically to the individual parsers. And I think that will finish this piece of this project. Thanks for joining today. Next time will be Monday. Oh, is that November or oh, it's the 31st? 28, 29, 30, 31? I don't know. Whatever day Monday is, I've lost track. It's either the 31st or November 1st. And let's see, then time is Eastern time, 1 to 3:30 p.m. or UTC 6 to 8:30 p.m. Thanks for joining today. Hope I catch you in the future. Take care. Bye-bye.